exist, the roots which do not exist in reality. So nature of roots means that you are solving the equation and trying to find the value of x as mentioned here. Like these are the two real roots of the equation. But sometime, for example, I get x is equal to under root minus 1. Under root minus 1 has no solution in math or add math. So we call this is an imaginary root. Imaginary means that this actually do not exist in actual value. So we have the first thing to understand. Discriminant is a mathematical formula b square minus 4ac. Rule number 1, if b square minus 4ac is less than 0, the roots are imaginary. It means that the roots will be not coming in the calculator. Then, second point, part 2, b square minus 4ac is equal to 0. This means roots are real and equal, like both roots are coming the same. Rule number 3, if b square minus 4ac like b square minus 4ac, look at the fourth rule, third point, b square minus 4ac. Can you hear me?
Yeah, I can.
B square minus 4ac, b square minus 4ac is greater than 0, which is a positive number. When it is a positive number, it means the roots are real and unequal, which we just solved. And the last b square minus 4ac is equal to 0. It means the roots are real. Achha, the last option, which is merger of the fourth rule, is the merger of the two. The word is meet. When examiner use the word meet, when examiner use the word meet, it actually means that the roots are the roots maybe are the value of x in an equation. This is a general word, but when he says greater than or equal to, it means the roots are real. Real, the word real means that the numbers which exist in reality. So now you have to give this heading in your notes and you have to take a picture of it. Very important rules.
Wait, sir, you said something about how the examiner uses the word meet, and so it means that all values of the roots are real?
The word meet, but then I later thought that first I have to cover this concept that roots are real and equal. Roots are real and distinct. So real and distinct means real and unequal. So actually, first we should do at least one example on this, at least, so we know what we are doing. And then the word meet can come up. The word actually meet is a word used when lines and curves are cutting each other. So now you have to remember first you should memorize the rule and then you have to copy this.
Okay, done.
So you must have taken the picture of it. Can you repeat the rules? Nature of roots means without solving a question, you can predict what type of roots will come up. What are the roots? Roots are the values of x, or you can say the solution of an equation. Roots are the values of x in an equation. Now, exercise 4.2, question number 1, A part and F part.
Okay. The question has already specified when the roots are real.
Hmm. Okay. I got your point. Uh, but let's actually first do one question, and we can answer this question, this point also. Exercise 4.2, question 1, part A.
All right.
Okay. Have you read the question?
Yes.
Okay, that's good. Now you have to see 1A. Question number 1A. Find the nature.
Yeah.
So,
The nature is equals to 24. 24 is greater than 0, so it's real.
24 is the nature and 24 is the value. The roots are real and distinct.
Yeah. And then it asks to find the roots.
If the roots are real, we will put it in our formula, the quadratic formula, and we will solve for it.
Yes.
This is if the roots are real, you can find the roots.
Yeah, I'm just doing that. So the first one I got was 1 plus under root 6, and the next one I got was 1 minus under root 6.
Hmm.
And will they ask us for a decimal form or
No,
ask under?
it's fine here in this question.
Okay, so then I got 3.45 and negative 1.45.
Hmm.
It says
Okay.
3.44 on your screen, but sir, aren't we supposed to round off because it's 3.449?
Acha. Maybe then the student told me a different number. You are getting 3.449, then it should be 3.45.
Yes.
Okay. Now look at orally the part number F. We first open the bracket, we simplified the equation and we solve. We got 28. 28 is a real, 28 is greater than 0. So the roots are real and distinct. When the roots are real and distinct, we can find the value by the quadratic formula. This is a similar case as we have solved. Now look at question number 2. The equation says x square plus k is equal to 6x. The roots, the question says the roots are distinct and real. He is asking for the range. Now you have to look up the question number 2. Make
Yeah.
the data.
Find the range of values of k.
Yes.
And it says it has two distinct real roots.
Huh. This is the b square minus 4ac rule. Now, first you simplify, you move the 6x on the left hand side, you make a common function there and find ABC and then
Sir,
apply.
k, sorry to interrupt, but is k the constant?
K is a constant. K is an
Okay.
unknown. K is an unknown constant, and this is like a unknown letter, and it can take any value. This is actually we are looking for K. So in that sense, K is the unknown of this question. So you first simplify the question. You make it on one side. Remember, K is a constant. It should come in the last. A square, ax square plus bx plus c, and then apply b square minus 4ac. So once you apply b square minus 4ac, you will get the equation like this. Then in the IGCSE style, it's an inequality. It's coming k is less than 9. I have shown it on a number line also. So please copy this working. On over this weekend, it's all clear, right? No issue, no? Because we are actually filling up our previous classes.
Yes, it is clear.
Good.
So, sir, if questions like this show up and it's immediately an inequality, then we have to solve that inequality.
A basic IGCSE inequality question. Number line is an option. Number line is an option. It is not necessary to draw a number line, but it always gives a better view.
Right.
Okay, so we move forward.
So, how are we on question 14?
We did number 2 now.
Yes.
So now we have our notes to fit in. This is notes should be always try to keep them in separate way so that they always come don't get disappeared between the questions. Now this is a rule. Real roots means b square minus 4ac is greater than or equal to 0. Now, if you want to prove that the roots are real, you have to prove the system is greater than plus. How we can prove the system is greater than plus? We can prove it by two ways. Answer is a positive number. Answer is a completed square. First rule everyone knows, because when you say greater than 0, it means positive. Second is very interesting. When something is a completed square, it will always be positive. Why? Because if the value inside is negative, it is actually negative, but it is actually will become plus after squaring. So now you have to copy this rule in the notes.
Yeah, I get it. But in the second rule, I mean, I get that if you have a negative number inside an under root, then it's equal to I, imaginary. But I
No,
didn't get what you meant after.
the first is very simple. Just like we were solving and we got 28. 28 is a positive number. It means second is that if you got a equation and you turn it into a completed square, if you complete square the equation, you can prove that the equation represent real roots. For example, I have an equation given and I reduce the equation and I get a final form like this: 2x minus 1 whole square plus 3. Now, this equation is a guarantee that this expression is always what? Can you tell
Positive.
me for any value of x, how this expression can be, how this expression can be always positive for any value of x?
It's because when it's a negative number, you multiply two negatives together, it's a positive result.
Yes, good.
Okay, I get it.
So you copied it, and this is the rule for this topic. Now we move to our line and a curve rule. This is our next notes title. When you interact with a line and with a curve, when you come across a line and a curve, when you come across a line and a curve, so first give the heading, line and a curve.
Okay.
It's a case when you are dealing with a line and a curve. There are different options available. Like rule number one, line is a tangent to the curve. Rule number one. Sorry. If a line is a tangent to the curve, the b square minus 4ac should be equal to 0. A very, very famous condition which comes nearly in every paper. Why the line is a tangent? What's the meaning of line is a tangent? It means it is touching at one point. When there is only one solution, it means repeating root. The b square minus 4ac should be equal to 0. Remember to make a combined equation from the two given equation. Okay, now you have to copy this rule number one with the diagram.
Sir, well, what about the part where you said when the word meet is used by the examiner, it means that the values of roots are.
Come here, the word meet. The word meet means the curve, the line may be is a tangent to the curve, or the line may be cutting the curve. The word meet is used in two possible meanings. So first, have you copied it?
Yes.
Okay. Now look at the rule number two. The line is cutting the curve. When the line is cutting the curve at 2 points, then b square minus 4ac is greater than 0. Why? Because it means that there are two distinct roots. You have to copy this.
Done.
Rule number four. Rule number three first. The line not cutting, the line is not cutting, not touching the curve, and it's going means no solution, no solution between the line and the curve. There is no solution between the line and the curve. This is rule number three. It means no solution. Acha, whenever an equation has no solution, it means it has an imaginary solution. It's a very interesting rule in Add Math. Sometimes math people get annoyed with math, but it's a very interesting rule. Add Math says that when you have no solution, it means you have an imaginary solution. And people says what's the meaning of this? It's a very interesting rule in math that there is nothing which cannot be solved. So suppose under root minus 1 has no solution, but Admet says that's right, it has no solution, but there is an imaginary solution. It means when you say nothing, math says it's 0, and 0 is a number. So nothing is represented by 0, but 0 itself is not nothing. 0 is a number. So this is the concept here. You have to copy this.
So can't we just write it's equal to I imaginary?
I imaginary is actually the letter I you sometimes get on your calculator doesn't represent imaginary. It represents a powerful letter in maths which is called iota. And you will inshallah study this in A-level maths. This is a concept of imagination and you use it to solve imaginary solutions. So
Hmm.
now you have to
Right.
copy the
Okay.
rule number
Got
4. Sometimes examiner use the word meet. Acha, meet means there are two options. Maybe it's a tangent, maybe it is a tangent, and maybe it is a line cutting. So rule number 4. So you have to copy this.
Okay.
Now we have the 4 rules. Now look at question number 18. Open this question in the book.
Okay.
Find the value of C such that the straight line whose equation is this is tangential to the curve with equation this.
Tangential.
This is a term used like a tangent to the equation this. So if 3x square minus 6x plus 5 is a curve. 3x square minus 6x plus 5 is a curve. Now, this is the question. You have to first make the data.
All right. So we're supposed to find C.
Hmm. Now, what we do first, we will merge the two equations. This is the first step. You have to merge the two equations to get a common equation. This is just like starting a simultaneous solution. You merge the two equations first.
Yes, that's what I did.
Hmm.
So 5 minus A is 3, B is equals to minus 8, and C is equals to 5 minus C.
Good. Now b square minus 4ac is equal to 0.
Is equals to 0.
Because
That means that it's rule 1.
yes, it's rule number 1. Whenever the function is a tangent, whenever a line is a tangent, you will get it like b square minus 4ac is equal to 0. Why? Because tangent touches a curve at one point. One point means one solution. One solution means b square minus 4ac is equal to 0.
Right. So when it says tangential, does that mean that it's always going to be rule 1?
When it is tangent, it means rule number 1.
Right. So for C I got negative 1 upon 3
Hmm? Negative 1 upon 3, right?
or 0.333 infinite.
Infinite? No, no. Why infinite?
No, I meant that it like as a decimal, the 3 is it's non-terminating, it's recurring.
Me, I'm not getting it. Sorry.
I meant that when you convert it to decimal, it's a recurring.
I'm just so sorry. Actually, I was thinking of giving an alternate solution. You are saying you're converting it into decimal. Okay. So
Yeah.
remember that an exact form is always preferable. An exact form is always preferable than a decimal form. Now we move to our next title, that is inequalities, and this is going to be our next and the last title of this chapter. This chapter is quadratics, and give the heading inequalities.
So does that mean we complete the chapter simultaneous equation and quadratics?
This chapter has not completed yet, but inshallah, we should try to complete it today or inshallah today, hopefully. But that is on the cost of decreasing question per topic, because I want to do as a few actually proper topics so you can sit for the exam. We will reinforce the topic from the past paper, inshallah.
Yeah,
Inequality.
it's fine. I can do questions on my own as well, so you don't need to worry about
But
that.
minimum, as a teaching rule, I tell you what, minimum two questions, 2 to 3 questions on every concept should be done. When we go to workshops now, they say
Yeah.
a minimum 3 to 4 questions on every concept, like concept number one, concept two. So today we discussed discriminant, we did 2 questions. So that's a minimum requirement. Anyhow, no problem, inshallah. This chapter is not tough. So inequalities is my next title. Give the heading. Now look at the first rule. In inequalities, when you change the sign, rule number one, when you change the position of the variable, you have to change the inequality sign. Rule number two, when you shift negative from one side to another, you have to change the sign. If there is negative on both sides and you want to remove the negative sign, you have to change the sign. So now you have to copy, you have to take a picture of these rules. You can copy later, but you should absorb them. Copy is not a problem. Actual thing is what we are showing is important. That inequality sign reverses in some particular situations.
All right. Understood.
Quadratic inequalities. Give the heading.
Okay. Done.
Case number one, if there are two brackets in a factor form and there are two brackets in a factor form, and you can see that the case number one is the inequality sign less than. Acha, when a question says less than inequality, you have to give the answer in a connected inequality, like A is less than X less than B. It is called a connected inequality. Look at this right hand side, that X minus A, X minus B less than 0. So A is less than X less than B. You have to now look up this. You have to
Okay.
rule number one or case number one.
Hmm. So they've already specified in the question that A is smaller.
Huh. And then they're not always. You have to, I tell you after the completion of the rule number two also, that you have to create a 0 on one side always. You have to
Yes.
create a 0 on one side.
But what about like less than equal to or greater than equal to? Then how would you even decide the? Okay, never mind. Got it. It's a case. Okay, so what's next? But sir, another question. If it was modulus, then the part below, then it would go up. And would they ask modulus in this?
Modulus is part of our course, but not in this chapter. It will come in another chapter, which is a mega chapter, a king size chapter, function. But quadratics support that chapter. But in quadratic, modulus is not a case. Modulus means always positive. The modulus sign means you won't go in negative. Now look at the second case here. The second case means the inequality sign. Look at the second case. The The second case is that x minus a, x minus b is greater than 0. Now you split the inequality, x is less than a or x is greater than b. To apply these rules, right side must be 0. Now look at, copy this rule, rule number 2.
Okay, done.
Look at the sketch.
But what about the sketch for case one? It'll just concern.
This is the sketch for case number 1 when you have to create the points in between.
Right. Sir, can you also explain these one by one?
We have to look, these are rules. We have to get the questions actually. That will be the explanation. So you have to copy the sketch for case number 2.
Done. Done all of that.
Now, exercise 4.3. Exercise 4.3, question number 1.
Which part?
Now, find the solution set of each of the following quadratic inequalities, part number A.
Okay.
X squared is greater than 9. So look, first you think you have to do is to move the 9 to the left side. Look at the first step. Do the first step with me.
All right.
Then look the second step.
Okay.
Then Now, match the rule number 1 or rule number 2, which matches here. The symbol is
Uh,
greater. Right side has 0 now.
yeah, so that means that it's going to be case 2.
Okay. When it is case number 2, you will write the answer in this form.
Oh no, that's case 1.
No, it's case number 2. Greater sign. Na?
No,
Case
in,
number 1 has a less than sign, and case number 2 has a greater sign.
okay.
Is there any error in that copy?
No, it's right. I understood from that, but just one thing I wanted to ask. Why
Hmm,
don't we just go straight with the x square and put square roots on both the sides? Then it
that's a good
cancels
question.
out.
It's a good question, but in case of inequality, we cannot do that. Because under root means plus minus. Overall, the answer would be the same, plus minus 3. But inequality answers cannot be solved directly. Taking under root is not a problem. You will get two values, plus 3 and minus 3. But that won't change the numbers. You have to use the rule to write down the final answer.
Okay, fine. Okay, so which part next?
Hmm. So you write the first answer in this way. There should be a 0 on the right hand side. Left hand side should be in factor form. So these are the two prerequisite conditions for this method to apply. So copy these two conditions also.
All right. I'm done.
Okay. Now look at this. Part number E. Now start question number part number E. Read the question and we have to start part number E.
Okay. So it's the same question. Find the solution set for each of the following quadratic inequalities, part E.
Hmm. And you have to generate a z on the right hand side.
Okay. Plus 12x squared minus 4x minus 12 is greater than 0. Sir, over here, factorization will occur, right?
Breaking the middle term.
Okay. I'll practice that on my own then.
Huh. Complete it and see the final answer should be in a split inequality form.
Um, let's see. So it says then if x is on greater than 0,
Hmm.
then I get x is greater than 6, then x is less than -2. So
Whenever the
then,
whenever the inequality sign is greater, you have to write a split inequality.
right.
Let me know once you have copied.
Yeah, I'm done. I solved it on my own.
Good. So when the inequality sign is greater, you will do that. Now look at this working. Inequality sign is this time less than. So first you create a zero on the right hand side, then you simplify. But once you get the final answer, you will write a connected inequality. You have to take a picture of this part. You have to take a picture of this part and you have to see the working, especially see the final answer. Okay.
Sir, I get that, but what if it's greater than equal to? Then we'll do the same?
The greater than equal, just like the part we did before that, you have to give the answer into separate forms.
Okay. So whenever we have greater, so it's split. Whenever it's less than, it's not.
Yes. Yes. When you have a greater sign, it's a split answer. When you have a less than sign, it's a connected answer.
Okay. Understood.
So we have finished the quadratic inequality. Actually, you'd have to take a picture of this and you have to solve part F
Okay. Done.
and you have to take a picture of part I.
All right. I'll solve these.
Okay. So this is the end of quadratics and we will mark some questions inshallah in our next class. The idea is simple that we will first try to do those chapters which can be done quickly and they have proper questions. So instead of starting a long chapter, which eventually end up with one question, obviously the time factor is the main thing. So we'll inshallah start a new chapter in our next class.
Okay.
I will
Fine.
try to put a class tomorrow also, but I will send you a message. If you are free at that time, we will try to put a class tomorrow, inshallah.
All right. Thank you.